The purpose of the first lab was to observe the motion of an object moving at a constant velocity without changing direction, and to apply Newton's law, second law, to the data. Now, I used the application tracker to show the motion of a ping pong ball of 40 millimeters diameter, which is also 0.04 meters, gliding on a ping pong table for a total of 3.405 seconds. Now, we have to assume two things. Number one, y equals 0. And we have to assume this because the y's are so tiny that it becomes insignificant. We also have to assume that the net force equals 0. And we can show this using a free body diagram. The free body diagram shows that all of the forces combined together negate each other and make it 0. Now, the pushes and pulls up from the table can be calculated using something like a free body diagram, and it would be shown later. Now, let's talk about Python. So, with Python, I changed the vector of the ball to 0.0100 because it started at 0.1 and not 0 for x. And the velocity was negative 0.3900. And the velocity was found by doing a slope. And you could find the slope by looking at 2 points, and I did the first 2 points of the data to find negative 0.3900. Now, delta t was found using tracker by looking at the difference of the 2 times. And another change was that t is now less than 3.405 seconds because that's how long tracker was being used for. And then also, as I said before, force equals 0, so you're going to have to use the 0 vector. And then, as you can see, we have the velocity of the ball and the position of the ball's formulas together, and also the t formula. T is time. And now, if you look at this, we have the VPython graph, and it showed that the ball is going in a negative x direction. And you can also see this because the slope of the second graph is negative x. Now, if you were to look at the position versus time graph, you could see that the prediction motion is straight, and that the observed motion is not straight. And that is because of the point mass changing in each different direction, and also is because of the drag that was on the table. During the video, what happened was that there was some issue with the camera work, and that screwed up the data a little bit, which gave us a little gap towards the end. But that's okay because it showed that towards the beginning it was completely in line with the predicted motion. So it should have been in line with predicted motion, but it was not. Also, if you were to look at changing the axes, you can see that everything would be going in the negative y direction and would therefore show different vectors. So you would have to change the data and change Python altogether, and that becomes a complete mess. And thank you, and good